Hi there and welcome to our next video on elastic potential energy. In this video we're going to be looking at what elastic potential energy is, the formula and some practice questions to end off with. So first of all, what is it? So elastic potential energy is the energy stored in an object when it's being stretched or compressed. Some examples might include a bouncy ball, it might include soap, it might include a rubber band, it might include maybe a spring. We can stretch and compress that. The equation for elastic potential energy is 0.5 or a half multiplied by the spring constant, which is measured in newtons per meter, multiplied by delta x squared. So this delta, the symbol is a triangle, and this means change in. Delta means change in, and in this case it is the change in stretch. So how much has the object been stretched from its original shape, and we have to square that. It is measured in meters. So we have 0.5 multiplied by the spring constant multiplied by the change in stretch, and all of this is measured in joules because all formats of energy is measured in joules. So the extension, as we've discussed, is the change in length. For example, if we have a rubber band over here and the length of this rubber band is maybe 3 centimeters, now we stretch this rubber band to make it bigger, and the length of this rubber band that we've stretched is maybe 8 centimeters. Then the difference between that would be 5 centimeters, and this is the extension. This is what I've drawn here, the extension of the rubber band, of how much we've stretched it from the original shape. The spring constant is the stiffness of the string, and this is how hard it is to stretch. So some springs are harder to stretch than others. So now let's have a look at some practice questions. A suspension spring is compressed by 0.2 meters and has a spring constant of 500 newtons per meter. What is the elastic potential energy which is stored? Step 1 is to write out the formula, which is 0.5 multiplied by the spring constant multiplied by the change in stretch squared. Don't forget your squared. So we have 0.5 multiplied by the spring constant, which is in the correct units, newtons per meter over here, multiplied by 500 multiplied by the change in stretch squared. So we have the change in stretch, which is 0.2 meters because it's being compressed, and it's being compressed by 0.2 meters. We have the correct units, so we can do that, 0.2 meters, and all we need to do is square that. So we have to input this calculation over here into our calculator, and that should give us the answer, and the answer is always in joules because energy is measured in joules. So if we were to work it out over here, 0.5 multiplied by 500 is just half of 500. This would give you an answer of 250. So we've worked this bit out over here. Now what is left is to multiply it by 0.2 multiplied by 0.2. So 0.2 is simply 2/10 of 250. That would be 50. And multiplied by 0.2 again, it would be 2/10 of 50, which would be 50 divided by 10 multiplied by 2, which would give you an answer of 10. So we know that the elastic potential energy stored in the object is 10 joules, and that is our final answer. Next question. A trampoline spring is extended by 15 centimeters and has a spring constant of 0.4 kilonewtons per meter. What is the elastic potential energy stored? So over here we need to do a bit of converting. So first of all, we need to write out the equation. 0.5 multiplied by your spring constant multiplied by your change in stretch squared. So we have 0.5 multiplied by our spring constant, which is 0.4 kilonewtons per meter, multiplied by 15 centimeters. Converting that, it would be 0.5 multiplied by, this is 0.4, so we have to multiply this by 1000, which would give us 400 newtons per meter, multiplied by, over here we need to divide by 100, which would give us 0.15. So we can just input this calculation over here into the calculator, and it should give us the correct answer, which is always measured in joules. In the description box below, there's a link to a quiz which you can have a go at. In our next video, we're going to be looking at some exam questions to do with elastic potential energy. But for now, that is it for this video. Thanks for watching. I hope you liked it. And one last thing, please subscribe, hit the like button and the notification bell.